Right, hello everyone and welcome back to my YouTube channel. In today's video we have something very important, like always, right? Today's we will be talking about exponential equations. So, what are exponential equations? Before we start with some of the examples and before we start with some of the past paper questions, I would like us to revise it a bit. First of all, what are exponents? So if we say, for example, number 32, to write it as a power of 2, then we can write 2 to the power of 5, right? Because 2 multiplied by 2 by 2 by 2 and one more time by 2 is equal to 32. So 2 to the power of 5 is equal to 32. What if we have, for example, 5 to the power of 0? We know that that is equal to 1. If we have 5 to the power of 1, that is equal to 5. So that remains 5. But what if we say 5 to the power of negative 1? Then we write it as a fraction and then our exponent becomes positive. So it will be 1 over 5 and then the exponent becomes positive 1, which is basically equal to 1 over 5. Alright, that means if we have 5 to the power of negative 2, it will be 1 over 5, and then we copy the exponent to make it positive. 1 over 5 to the power of 2, which is equal to 1 over 25. Lastly, let us try, for example, 1 over 64. What is 1 over 64 if we want to write it as, for example, 4 to the power of something? First of all, 64. 4 multiplied by 4, 16. Multiplied by 4 is equal to 64. So 4 multiplied by 3 will give us 64. But because it's 1 over 64, then our 3 must have been negative. Okay, these are the basics. If this is clear, then we can start with some exponential equations. For any exponential equation, first of all, what are exponential equations? Those are equations that have variable in the exponent. So if we have, for example, 2 to the power of x is equal to 2 to the power of 5. In order to solve an exponential equation, we need to have same exponent. We need to have same base. So we have base of 2 here and base of 2 here. If our bases are the same, then we only say our exponents must be equal as well, which means x is equal to 5. So there is nothing to be solved over here, right? But what if we have 5 to the power of 2x is equal to 125? Oh, so what did we say? We need to have the same base on the left side and on the right side, and then our exponents will be equal. Okay, what happens with 125? How can we write it as 5 to the power of something to give us 125? You multiply 5 by 5 by 5, and that will give us 125, which means 5 to the power of 3. Excellent. I will replace this. Instead of writing 5 to the power of 2x is equal to, instead of writing 125, I will write 5 to the power of 3. Perfect. We have equal base here and here. Now we just say 2x is equal to 3. We're almost done. Divide by 2, divide by 2. X is equal, this goes away, to 3 over 2. That's it, we are done. So basically the logic behind exponents is make sure that you have equal exponents. If our exponents are equal, if our bases are equal, then exponents must be equal as well. Okay, let us see some practice questions here. The first one, 3 to the power of 2x minus 1 is equal to 81. First of all, 81 can be written as 3 to the power of what? You know that you multiply 3 by 3 by 3 and by 3 one more time to get 81. So 3 to the power of 4. Alright, so the only thing we need to do is 3 to the power of 2x minus 1 is equal to 3 to the power of 4. Now that our bases are equal, exponents must be equal as well. Alright, we can say that 2x minus 1 is equal to 4. Right, this is some grade 7 knowledge equation. We move minus 1 to the right side, we make it plus 1. So 2x is equal to 4 plus 1, 5. Last step, divide by 2, divide by 2. So x is equal to 5 divided by 2. You can say 2 and 1/2, or you can say 2.5. That's it, we are done. Alright, next question. 2 to the power of 3x minus 1 minus 2 is equal to 32. The only thing we need to do is 32. It must have been written as 2 to the power of what to give us 32? You know that you have to multiply number 2 5 times by itself to get 32, so the power is 5. Excellent. We just say 2 to the power of 3x minus 2 is equal to 2 to the power of 5. Almost done, right? We only say 3x minus 2 is equal to 5. Switch 2 to the other side, make it positive 2. So 3x is equal 5 plus 2, 7. Divide by 3 to get rid of it. X is equal to 7 over 3. Again, we can write it as a mixed number if we want, or as a decimal number. I hope this one was clear. Let us move on to the next one. Okay, on the left side we have number 8. On the right side we have 1 over 32. First of all, 1 over 32. It means that our exponent was negative to give us 1 over 32. But the problem here is, on the left side we have number 8. On the right side, can we make it 8 as well? Can I say 8 to the power of something is equal to 32 or 1 over 32? Nope, we cannot. So what we need to do is, let us make the same base on the left side and on the right side. What do we mean by the same base? Can I write 8 as 2 to the power of something? How many times do we multiply 2 by itself? Oh, 2 times 2 times 2. So 2 to the power of 3. Now, let me replace 8 by 2 to the power of 3. Oh, do not forget to copy the exponent. The exponent was x minus 2. While on the other side, 1 over 32, it will be 2 to the power of what? What did we say? In the previous example, we said that 2 to the power of 5 is equal to 32. But because it's 1 over, we said that in the beginning, the exponent must have been negative. Oh, 1 over 32 will be replaced by 2 to the power of negative 5. Excellent, we are almost done. What do we have on the left side? 3 multiplied by x minus 2 is equal to negative 5. Let us expand the brackets over here. So 3x minus 6 is equal to negative 5. Switch negative 6 to the other side and make it positive. 3x is equal negative 5 positive 6, 1. Final step, divide by 3, x is equal to 1/3. All right. So, what was important here? It was important to have the same base. we can write both of them as 2 to the power of something. So we can say that instead of 8, it was 2 to the power of 3. But then do not forget to copy the exponent. Instead of 1 over 32, you can write 2 to the power of negative 5. Perfect. This exponent must be equal to this exponent. We solve this basic equation and we get the final answer. All right. As you can notice, questions are getting more and more difficult. So we started with basic questions, then step 2, now more difficult, again more difficult, just a bit more challenging. Now we start maybe with the most difficult one. Look what we have. 9 to the power of x plus 1 is equal to 27 to the power of 2x minus 1. Oh, what do we notice here? There is a variable in both of them. Fine, no problem with that. But what do we need? We need the same base. Can I write 9 to the power of something to give me 27? It doesn't work, right? So we need the same base for both of them. We need 3. Instead of 9, we can write 3 squared. Do not forget to copy the exponent. Instead of 27, we will write 3 cubed. Do not forget to copy the exponent. Excellent. Now that we have same base on the left side and on the right side, we just say that 2x plus 1 is equal to 2x minus 1. All right, expand the brackets here. 2x plus 2 on the right side. 3 times 2x will be 6x minus 3. Now we move 2x to the right side, negative 3 to the left side. What does it become then? 6x negative 2x to positive 3. 2 plus 3 is equal to 5. 6 minus 2 is equal to 4x. We know that we have to divide by 4, right? Final answer. X is equal to 5 over 4. That's it, we are done. All right. What we have here, guys, is 2 questions from past papers. So here is the first one. This is IGCSE past paper questions. Here is the first one, and here is the second one. Let's go over this one first. What do we have? 3 to the power of x multiplied by 2 to the power of x is equal to something. First of all, on the left side we have 3 to the power of x multiplied by 2 to the power of x. They do not have the same base, but they have the same exponent. There is a rule in algebra that says a to the power of x multiplied by b to the power of x. We can combine a and b to the power of x. So we multiply a and b to the power of x. Oh, what does that mean? We multiply 3 and 2 and then to the power of x. So instead of writing this, we can say 3 multiplied by 2 is 6. 6 to the power of x is equal to 279,936. Now, you can actually try trial and error and you will see 6 to the power of 1 is 6. 6 to the power of 2 is 36, and so on. Finally, 6 to the power of 7 is equal to 279,936. But you are allowed to use a calculator for this exam, so then you can just calculate this on the calculator. So that was the idea, to multiply the bases and then say to the power of x. The last question for today, a to the power of 4 over 3 and then 32 to the power of x. Remember, we need the same base for both of them. Now, for the first one, instead of 8, we know by now that we can write 2 to the power of 3. 2 to the power of 3. Do not forget to multiply this by 4 over 3 because that's another exponent, is equal, instead of 32, we can say 2 to the power of 5. Do not forget to multiply that by x. All right, final step. This must be equal to this. What do we have on the left side? 3 multiplied by 4 over 3 is equal to 5 multiplied by x, which is 5x. Oh, 3 and 3 can be cancelled out. 4 is equal to 5x. Divide by 5 to get rid of it. Divide by 5. X is equal to 4 over 5. With that, we are done. Alright, I hope that we covered everything you need when it comes to exponential functions. Any questions you have, please make sure that you write a comment so that I can help you. Make sure that you check the description box to find more practice questions in this lesson. Subscribe to the channel to see more videos. I will see you in the next video. By the way, in the next video we talk about logarithm